Hey everyone, this is an example of a application problem from section 2.4. It's a draining a water tank problem. So a 300-gallon tank is initially full of water and is being drained at a rate of 10 gallons per minute. It wants us to write a formula for a function W that gives the number of gallons of water in the tank after t minutes. So if we want to write a formula with function W, and it looks like t is in minutes, we'll start by saying W of t equals something. So this is the output, which is the water output, and t is the input, which is in time. And then we're going to look at the information they give us. So they give us a 300-gallon tank, and we're losing water at a rate of 10 gallons per minute. So if you're losing water at a rate of 10 gallons per minute, that's at a rate of negative 10t. But you initially started with 300 gallons. So you're losing negative 10 gallons per minute, but you started at 300. So our function for this would be negative 10t plus 300. So the water with an input of time would give you negative 10t plus 300. And then it asks us for part B, how much water is in the tank after t minutes. Well, if we want to know how much water is in the tank after 7 minutes, we're going to say the water with an input of 7 minutes is going to equal negative 10 times 7 plus 300, which gives negative 70 minutes plus 300, which means it's going to be 230 minutes. So, or not 230 minutes, 230 gallons. How much water is in the tank after 7 minutes? 230 gallons after 7 minutes. And then in part C, it wants us to graph W. So we're going to graph W and identify and interpret the intercepts. So if I want to graph this function, I can write it as W of t equals negative 10t plus 300. And then I can either use a t-chart or I can identify that this is slope-intercept form, and I can draw a graph. I'm going to label this by hundreds. So this is 100, 200, 300. And then it tells me I'm dropping basically 10 gallons per minute. So I'll also label this as, let's label this as 10 minutes, every 10 minutes. So 10 minutes, 20 minutes, 30 minutes. And you'll see why I did that in a second. If I mark 300, which is my y-intercept, and then I go down 10 over 1, well, I'd have to make this, I'd have to be basically going up by 1 minute at a time. What makes this graph easier to see is if I go up by 10 minutes at a time. If I plug 10 in here, this will give 10 times negative 10, which is negative 100. Add the 300, you get 200. So if I'm going down really at 10 minutes, I'm going down 10 every minute. Well, after 10 minutes, I'm going down 100. So that'd be my next line. Then if I plug in 20, I get 20 times negative 10, which is negative 200. So then we would plot that there. And you can see I have a graph of my function, which looks like so. Now it wants us to state or find the intercepts. So if you remember to find the intercepts, if I want the x-intercept, I'm going to plug in 0 for y and solve for x. And if I want the y-intercept, I'm going to plug in 0 for x and solve for y. So if I plug in 0 for y, that's going to make this be 0 equals negative 10t plus 300. If I were to subtract this to the other side, that would give negative 300 equals negative 10t. And then I divide this by negative 10, and that'll give 10 equals 30. So this 30 comma 0, what is that? That's telling us, so this is the interpretation, after 30 minutes, I'm going to have 0 gallons of water. So this is 30 minutes, 0 gallons of water. You can see that on the graph here, is that after 30 minutes, I'm going to end up with 0 gallons of water. Now, if I plug in 0 for x, or for t here, that's going to give W of t equals negative 10 times 0 plus 300, which will give W of t equals 300, which means that this is now my y-intercept 0, 300. If you look on the graph, what does that mean? That means that no time passed, I have 300 gallons in my tank. So if we go back to the original problem where it says a 300 gallon tank is initially full of water, well, at 0 minutes have gone by, it's still full of water. So that's what the y-intercept is telling you. The x-intercept is telling you that after 30 minutes you're at 0 gallons, and the y-intercept is telling you at 0 minutes you're at 300 gallons. And then finally, part D is asking you to find the domain. Well, the domain of this function, so part D, I want to find the domain. The domain of this function is what are the number of basically minutes that I can plug into this function. Well, the y-intercept, the x-intercept basically give that away. The y-intercept says we start at 0 minutes, we have 300 gallons in the tank. The x-intercept says that at 30 minutes we have 0 gallons in the tank. I can't go anything less than 0 gallons in the tank. So my domain is going to be from 0 to 30 gallons. I'll write gallons out here.